The largest black hole ever found might not be the largest black hole ever found. For over a decade, astronomers pointed to one object and called it the heavyweight champion of the universe. Now the person who helped discover it isn't so sure. And the closer we look, the stranger the disagreement gets. Somewhere out there is an object so massive that if you dropped our entire solar system into it, nothing would notice. The question isn't whether monsters like this exist. It's how big they're allowed to get before the universe itself says stop. And one black hole, sitting at the edge of measurement, might be the one that finally tests that limit. In 2012, MIT astronomer Michael McDonald led the team that uncovered it, a galaxy cluster 5.8 billion light-years away, so bright in X-rays it had been hiding in plain sight. McDonald's team found something that shouldn't have been possible. At the center of this cluster, stars were being born at a rate of about 740 per year. For comparison, our own Milky Way produces roughly 1 star a year. Something enormous was feeding that furnace. They named the cluster Phoenix. And at its heart sat a black hole unlike anything cataloged before. Here's what makes a galaxy cluster's core so strange. Normally, a supermassive black hole acts like a bouncer at an overcrowded club. It blasts out radiation in jets of particles, heating the surrounding gas so violently that it can't cool down and collapse into new stars. Most cluster cores are quiet, almost dead, because their black holes are doing exactly that job. Phoenix broke the pattern. Its black hole was pumping out enormous energy, and stars were still being born in droves. Think of it like a furnace that's supposed to keep a greenhouse too hot for anything to grow, except somehow the plants are thriving anyway. That contradiction is the thread this whole story pulls on. Because to understand how something that powerful could also be that generous, astronomers needed to know one basic fact. Exactly how big is it? In 2016, a team of astronomers tried to answer that question using an indirect method. They modeled the relationship between a black hole and the size and stellar density of the galaxy that hosts it. Feed that model the numbers for Phoenix A's host galaxy, and the answer that fell out was staggering: 100 billion solar masses. That would make it the largest black hole ever identified in the universe. Bigger than every other candidate on record, by a wide margin. For a few years, that was the headline. Phoenix, a star, was crowned, but a number derived from a model isn't the same as a number derived from an object itself. And nobody had actually measured it directly. That should have settled the question. It didn't. In 2019, Michael McDonald, the same astronomer who helped discover the cluster in the first place, led a new study, this time combining data from Chandra's X-ray observations, the Hubble Space Telescope, and radio data from the Very Large Array. This wasn't a model extrapolated from a host galaxy's size. This was multiple direct lines of observational evidence, triangulated. And the number it produced was nowhere close to 100 billion. It came out to roughly 5.8 billion solar masses, not the biggest black hole ever found, a small fraction of the crown it had just been given. So which one do you believe? The model or the multi-instrument measurement made by the person who found the thing in the first place? Because if 5.8 billion is closer to the truth, Phoenix A star isn't even close to the biggest black hole we know about. Someone else has held that title for a very long time. Its name is TON 618, and it's been waiting in the dark since before anyone knew what it was. TON 618 first showed up in 1957 in a photographic survey out of the Tonantzintla Observatory in Mexico. The astronomers who logged it thought they'd found a faint blue star. Quasars, the blazing black hole-powered cores of distant galaxies, hadn't even been identified as a category yet. That wouldn't happen until the 1960s. It took follow-up radio observations years later to reveal what TON 618 actually was. Not a star, but one of the most luminous objects in the observable universe, powered by a black hole now estimated at somewhere between 40 and 66 billion solar masses. If Phoenix A star really is only 5.8 billion, TON 618 doesn't just win. It isn't even a contest. But here's the foreshadow line worth sitting with. Estimated. Every single one of these numbers, Phoenix A stars, TON 618's, all of them, comes with an asterisk, and that asterisk is the real story. There is exactly one gold standard way to weigh a black hole. Watch the stars orbiting closest to it, time their loops, and use gravity to back-calculate the mass pulling on them. That's how we know Sagittarius A star, the black hole at the center of our own galaxy, weighs about 4 million solar masses. We can resolve individual stars close enough to it to track their orbits. We cannot do that for Phoenix A star or for TON 618. They are billions of light years away. No telescope we have can resolve individual stars orbiting their event horizons. So astronomers are left with proxies, X-ray brightness, host galaxy scaling relations, gas dynamics, emission line widths, each one an indirect stand-in for a measurement we can't actually make. And these proxies don't agree with each other. That's not a footnote. That's the entire reason this argument exists. So maybe this was never really a rivalry between two black holes. Maybe that's the wrong question entirely. Because buried in the disagreement over Phoenix, a star's mass is a stranger, bigger question that has nothing to do with rankings. Is there a ceiling? A hard limit on how large a black hole is even allowed to become? Yale astronomer Priyamvada Natarajan thinks there is. Her research proposes that ultramassive black holes eventually choke on their own success. As they grow, they radiate so fiercely that they blast away the very gas that was feeding them. They starve themselves. Natarajan's work puts that ceiling at roughly 100 billion solar masses. Not an estimate of what one object weighs, a theoretical wall for the entire universe. And in 2025, James Webb Space Telescope data on the Phoenix cluster confirms something unsettling. The gas is still flowing in. The black hole is still active, still feeding. It has not starved itself yet. Which means Phoenix, a star, isn't just disputed. It might be a black hole still climbing toward the one number nothing in this universe is supposed to be able to pass.